So number 22, you got to be very careful just with the wording. I already saw some confusion on this one. The key word is this word I'm underlining right here. Possible. Okay, we're listing the possible zeros of the function. If that word hadn't been there, if I had just said list the zeros of the function, well, that's when we're using our calculator and synthetic division, and we're finding how many actual zeros should there be for this function?
3.
There should be 3. Even if they're imaginary or irrational and all that, there should be 3 actual zeros. All right? But when I throw up this word possible, that means we're just talking about the remainder, the rational root theorem. Okay? So all we're doing is making that chart and listing the possible zeros in case if we ever had to like guess. So here's what we had decided. The possible numerators come from the constant term. Why did I put a D next to that? I don't know. I said the possible numerators come from the constant term. The possible denominators are going to come from the leading coefficient. Now when I say come from, I'm talking about this. All right, so numerators come from the 2, denominators come from the 6. When I say come from, I mean we're looking at the factors. So the factors of 2 are just 1 and 2. Those are the only 2 numbers that divide evenly into 2. What are the factors of 6? In order, go.
1, 2, 3, 6.
1, 2, 3, and 6. All right, those are the factors of 6. So we're going to have these numerators and these denominators, and I'm going to mix and match them. But I'm going to go in order, so I'm very careful not to miss any. So I'll start with a denominator of 1. That means I'm going to do 1 over 1 and 2 over 1. So that would just give me 1 and 2. Okay? Then I'm going to switch over to a denominator of 2. That means I'm going to do 1 over 2 and 2 over 2. So there's my 1 over 2. What about 2 over 2 though, guys? No, that's 1. We already have 1, so we're not going to write down 2 over 2. Okay? So now we're going to do a denominator. Whoa, that's erasing. Slow down. Now I'm going to do a denominator of 3. So I'm going to do 1 over 3 and 2 over 3. All right, those are both new, so I'll keep both of those. And finally, I'll do a denominator of 6. So that means I'll do 1 over 6 and 2 over 6. All right, Malik, do you have anything to add? Anything I need to do?
Well, I mean, it looked like 2 over 6 can be reduced to 1 over 3, so we can just erase that one.
Oh my goodness, you're right. 2 over 6 reduces to 1 over 3. We already have that, so we're not going to write it down. Okay? Jakai, do I have, am I at full credit now? Do I have 100% right now?
Yes, you do.
Whoa, whoa. Why do I only have half credit right now, people?
Because you forgot to do something.
I forgot to do something. Jump in there. Jump in there. Plus or minus. Everything has to be plus or minus. Okay, so don't forget, you got to put plus. Each one of these could be plus or minus. And no, you can't put one plus or minus in the front of the whole list. You got to do it on each one. Okay? So again, the key word is possible zeros. So if you see that word possible zeros, this is what we're looking for. How many actual zeros should there be?
3.
Only 3. So if we were to do this problem out, looking for the actual zeros, they should be on this list unless they're imaginary or if they have square roots in them. Otherwise, they should be somewhere on this list.